So you are using your notes from last class to answer. How do you solve this? You should know how to solve it, but you're going to write it down in words. How do you solve that? You are answering the first question on your notes. You're using your notes from last class. We already wrote it down. So you're using them to help you write it down for the day. The more times that we write something down, the more likely we are to remember it. Use your notes to write down from last class. How would you solve that problem? What would you do? Please put your phone away, take your headphones off. Writing things in math is hard. It's easier for us to show in math what we're doing. It's not easy to write down the math process in words. So I don't want anybody to feel flustered. Please take your time and write down what you do. What do you do to solve that problem? And it's okay to talk it through with your friend. Yes, take the pass, write your name and the time. Okay, let's think about how we can put this into words. So please don't erase if you said something similar, that yours doesn't have to be the same as somebody else's. Can anybody, or does anybody want to be brave and tell me what they wrote?
Andres, what'd you write?
Constant debate.
Say that one more time.
I put constant debate. Like, constant.
Oh, cancel the base. Okay. That pretty much is what you do. Anybody write anything different? Y'all both said something, so say what you said. What'd you say? So with logs, these are not exponents. So let's clean that up and make sure that we're writing the right thing. So I think we first had to identify that the log was the base was the same for the log on both sides. We know that they're the same. So when you have log base and it's the same, again, you could have written something different and you're meaning the same thing. So please don't erase anything. When the log bases are equal, you can set the stuff. Okay, so the stuff that's in parentheses, those aren't exponents. So don't call them exponents. If you call them exponents, then erase it and you could call it stuff. So when the log bases are equal, you can set the stuff equal and solve. And so, yes, that's exactly what you do. These cancel out, and then you set the stuff equal. So it's important that we remember what we did from the day before, because it's coming, it will be on our next quiz. In fact, today is our last day of content before we take our next quiz. So when log bases are the same, you can set the stuff equal and solve. And the only way this works is when it is 1 to 1. Has to be 1 to 1. Let's jot that down. Has to be 1 to 1. What that means is it has to be just 1 log equals 1 log, 1 to 1. That same thing happens when it's an exponential. It has to be 1 to 1. 1 log equals 1 log. Nothing else. Next, it says if 2 logs with the same base are on the same side of the equals, I want you to go and look at day 2. Get day 2. So day 2 is 7, 5, 7, 6. And so we wrote at the top, day 2. We're going to look at the back of day 2 notes. What were the directions for the back of day 2 notes? We were condensing. So I want you to highlight that word condense because that's what goes in the next blank. I always mess up spelling the word condense. I always want to put a C at the end, but it's an S. So you're going to highlight that word condense. And that's what goes in the blank. When we have 2 logs, they're on the same side, we will condense them. So 2 logs with the same base on the same side. So that is where we're going to take them and put them together. On the front of the day 2 notes, we have examples. So if you're adding we put them together and we do something. If you're subtracting, we put them together and we do something different. And so we have one example that has 2 logs, but they're adding, one example, and there's 2 logs and they're subtracting. So we're going to have to do something different for them. What do you do when you're adding? We're going to put it together and we multiply. So let's give ourselves a reminder. We will multiply. And what do we do when we're subtracting? Okay, so we're reminding ourselves what the operation is when we put them together. So when we're solving for this, I can't just mark off. I cannot just mark off these are the same log base. I've had log base 7 equals log base 7, but it is not 1-to-1 because I have 2 logs over here. If I just marked it out and then I had x is equal to 4 plus 8, that is incorrect. That is not right. We can't do it like that. You have to condense it so that it is 1-to-1 first. So first thing I have to do is put this together and I have to put this together. So I'm not going to talk it out loud because we should know how to put them together. So I want you to put them together on your own paper and then look up so that you can check. All I'm doing is condensing that side. Any questions over this first step where we're just condensing?
It's a single branch.
Because when you subtract, you will divide when they come together. I want you to take a look at your homework. Are there any problems on the homework? Because all we're doing is solving. Are there any problems on the front side? Because you're solving there. Are there any problems that have 2 logs on the same side? No. Okay, let's look on the back. Are there any logs that have 2 logs on the same side? Okay, it looks like number 10 has 2 logs on the same side. 11, 12. So I want you to give yourself a little note that either says you're going to multiply or you're going to divide based on whatever that sign is. Go tell yourself you're either going to multiply or you're going to divide. And then I'm going to give you 2 minutes because I want to see if you can do it. Just condensing. Okay, we're not even to solving yet. We're just condensing. The ones on the homework. Yep. The only thing that is slightly different with the homework problems, for these, you're going to have to distribute for 11 and 12 because it's x times, in parentheses, x plus 21. So you have to distribute the x into both pieces. Well, for number 11, it's x times x is what? X squared, and then x times 21 is just 21x. So we know that this stuff is gonna multiply that stuff. So it becomes x times x is x squared and x times 21 is 21x. So sorry, that's really loud. All right, let's regroup back on the notes. So on the notes at this point, I need to solve, my ultimate goal is get x equals. So when I look at this one, that's a lot like the stuff we did last time. We have log bases in there the same. Am I 1 to 1? I've got 1 log equals 1 log. I'm 1 to 1, so I can cancel. Easy peasy, right? Why are you shaking your head? Tell me what is the struggle for the first question. Okay, we're not at the homework yet. Okay, it's baby steps. Okay, it's baby steps. So are we good with number 1 then? Okay, because I need to figure out where we're struggling. So it's not with number 1. We're not struggling with number 1. Good. Okay, the second one, we don't really like dividing, but that's okay. We can still do this problem because what do? We have 1 to 1 log equals log. So what next? Yeah, let's cancel these out and let's set the stuff equal. We don't really like solving with fractions, but that's okay. We can do this. Okay, we need to get the x out of the denominator, right? We can't solve for x with it in the denominator. So how do we get it out of the denominator? If it's dividing, we must multiply. All right, but I still don't have x equals. So what do? Divide. So what is 16 divided by 8? Mhm. Okay, not so bad. Whether we're multiplying or dividing, we can do it. Down at the bottom, it says you can't take the log of a blank number. You can't take the log of a blank number. That's on the back side of day one notes. Very first blank, top of the page. Okay. You cannot take the log of a negative number. You cannot take the log of a negative number. With what? Because it's dividing here. And I can't get x equals if it's in the denominator. So the inverse of divide by x is multiply by x. That's how I got it out of the denominator. And then here, I don't have x equals. So to get x equals, I have to divide by 8. Basically, what happened was that the 8 and the x switched places. Okay, that's a really important one. You cannot take the log of a negative number. You cannot take the log of a negative number. So what that means is we need to check the answers. We need to check the answers for extraneous solutions. When you see the word extraneous, that means extra. There are extra solutions that don't work. Okay, when you have extraneous solutions, they don't work. So what we're going to do now is we're going to check the answers we just got. To check the answers, you don't need a calculator. All we're doing is double checking to make sure that if I took that x value and I plug it into the problem, am I taking the log of a negative number? So what I mean by that is we're going to take this 32. And if we took 32 and we put it in here, I'm taking the log of positive 32. So am I taking the log of a negative number? No, okay, I move on. That doesn't even have an x, that doesn't even have an x. So I only have one x to plug into. It's positive, so that answer works. Here, 2. Okay, I go plug it in anywhere there's an x. No x. An x. Okay. Positive 2. If I plug it in, am I taking the log of the negative number? Most of the time the answers do work, but you still have to double check. So with both of these answers, they work. You're not taking the log of a negative number. If you plug 32 in here for x, it's positive, so it works. If you take that 2 and you plug it into the x, it's a positive, so it works. On to the next problem. Okay, this one, I have logs on both sides. So again, I need to condense them because I can't solve the problem yet. So when I put these together, what does the addition sign tell me to do? Multiply. So the first step that we're doing is we are going to condense. So I left yourself a little bit of space so that you could write these things down. First thing we are going to do is we will condense. And so what we end up getting is x times x. What is x times x? Now what I have is the same situation as above. I have a log equals a log. They have the same base. What is the base? 10. That's right. What kind of log is this? Common log. I'm also gonna give myself a little note. Okay, it's a common log with a base of 10. We need to know that. All right. I am 1 to 1. I have 1 log equals 1 log. They have the same basis. So what do we do? So our second step. So when you're 1 to 1, you can mark them out. You're 1 to 1. So I'm going to set the stuff equal. This one is a little different than all the other problems we've done so far. Why? Because it's an x squared. So anytime that you have an x squared, we're going to solve it like a quadratic. So we are going to solve like a quadratic, and that means that we've got to make it equal to 0 so that we can factor. We got to make it equal to 0. Then we factor. Right now, to make it equal to 0, you want to check your x squared. If it's positive, you're going to leave it where it is. So is my x squared positive? Then I leave it and I'm going to move all the other stuff. So I'm going to move and subtract x, and I'm going to move and I'm going to subtract 20. Factoring. It's been a hot minute since we did any kind of factoring. So I'm going to remind you, for this kind of factoring, the leading coefficient is 1. When your leading coefficient is 1, you can fast factor. It's meant to be fast. So our goal to factoring is that we're going to get 2 factors. They're both going to have an x. We just got to find out what the numbers are. So to figure out what those numbers are, I'm going to get factors of 20. Factors of 20, I'm going to start with 1. 1 and 20. 2 and 10. 4 and 5. Can you think of any others? Am I leaving anybody out? Okay, so we need to figure out what factors of 20 can put together to give me 1. We might have to add or subtract. So we're going to have to use 4 and 5. And I go put them in there. That doesn't matter which order. Yes. Good. You always figure out your signs. The bigger number has to have the same size sign as the middle. The middle's negative, so my bigger number will be negative. So you check that sign in the middle, tells you that your bigger number is negative. And then the other one, if I have -5, do I add or subtract to get -1? Add. I'm almost done, but I don't have x equals yet. So y'all remember that when you have them and they're in parentheses like that, to get x equals, all we're doing is setting each one equal to 0. So for the first one, x plus 4 equals 0. So we would have to subtract 4. So x equals -4. The second one, you're adding 5. So x is equal to 5. Okay, we factored. We want to get x equals. Then our very last step, we have to check. We have to check for extraneous solutions. Why do we have to check for extraneous solutions? Because you can't take the log of a negative number. So checking for these, again, you don't need a calculator to check them. We're going to mentally go through and check them. So this first one is -4. If I take -4 and I plug it in, am I taking the log of a negative number? Yes, so it doesn't work. I don't have to check it in any other thing because it's already going to be negative. That tells me it doesn't work. So when you're doing a problem, if there is an extraneous solution, you must show me that you found a solution, but you're not going to put it in your answer. It's extraneous because it's negative. Okay, we got to do the same thing with the 5. If I take this 5 and I go plug it in, am I taking the log of a negative? Am I taking the log of a negative? Okay, this one we have to do some arithmetic. 20 plus 5 is 25. Is that a negative? No. Okay, 5 works. So my only answer for this problem, the only one that works is 5. All right, I want you to take 2 minutes and I only want you to do question number 10. We don't know how to do 11 and 12 yet. I only want you to do question number 10 on your homework. Go see if you can do question number 10 on your homework. Stop psyching yourself out. Tell yourself you can do it. Number 10 is a 1-to-1 problem. Hello.
If I could take a picture of the notes from last time.
Day 3. You know what? Oh, I brought them. Oh. I'm pretty sure I brought it home and I left it. But I could bring it tomorrow and let you take a picture if that works.
Okay, that's fine.
I have them uploaded on the in Canvas though.
Okay, so I'll tell for different.
Yes, the video is uploaded, so he can use the video.
Okay, good.
Did anybody do that problem and think you maybe got an?
tell you that the answer to that problem is a fraction. Thought maybe you were doing it, but then you thought, I gotta be doing something wrong because I'm getting a fraction answer. And the way that the answer is a fraction, it is a fraction answer. Very good.
All right, so we're gonna take a little mental break. And back by popular demand, we will watch. Huh? Like, because your phone hears you. Yeah, because makes you wonder why, huh? This must have taken like so much time to do these. That's crazy. That's crazy. I think he made like ramen. Very interesting. The popcorn one. Hello. Hey. Nope. Yes. That is interesting. She was definitely here though, because I passed out tests and I know that I didn't get one back from her. Like I didn't have an extra one that I didn't pass out, so. Yeah. Yeah. Okie dokie. Next, we're gonna talk about other types of solving. So onto the back. When you only have one log or exponential, because when we do 1 to 1, you have two of them, one on each side. So we have two. When you only have one log or one exponential in the problem, you must rewrite to solve. So when we rewrite, that's like when we take the log and we do like that. So if you want to give yourself a little reminder, that's what I mean to rewrite. So when I look at example 4, I have two logs, but they're on the same side. So when you have two logs with the same base on the same side, what do? Condense. So I didn't hear you guys as a group tell me that quick enough. So we definitely need to make sure that we condense. And the reason why we do that is because they're on the same side. Okay, two logs on the same side, you condense. So when we put them together, the operation is addition. So when we put them together, what are they going to be doing? Multiplying. So you had a few problems on your homework that were like that. And when you went to put them together, y'all did crazy stuff. So you might need to go erase some of those. When we put them together, we will multiply. That means that the two things I got to multiply. So since I've got one thing in parentheses, I'm going to have to distribute. So I get x times x squared, and then x times -4. What? What, is it noisy? And it's like squeaky? Oh, I hate them. She's giving you ugly looks. She's not appreciate you calling her out like that. Alrighty, from here, do we have 1 to 1? Do we have a log on both sides? No, there's nothing to cancel out. So these problems work differently. When there is not two logs to cancel out, you have to rewrite it. Okay, when we rewrite, we're going to use that little swirly thing. We're going to do 2 to the x is, sorry, 2 to the 5th is equal to that stuff. So it becomes 2 to the 5th power is equal to that stuff. What do you mean? Oh, that's me rewriting it. So when I rewrite That's when I do the swirly thing. So this is 2 to the 5th power is equal to this stuff. This is the swirly thing. This was just me showing you like the direction. 2 to the 5th power is equal to that stuff. At this point, we have no more log. But I do have an x squared. When I have an x squared, how do I have to solve it? Is this like the steps that we wrote down just above it? On the front page, we wrote down, we had something that was squared. So, and before you factor, you have to do what? Set it equal to 0. Okay, to set this equal to 0, I'm going to check the x squared. Is the x squared, is it positive? Leave it. Okay, so the x squared is kind of like the magnet. If it's positive, you leave it alone. Then you might want to move it to the other side. So I'm going to move the 2 to the 5th power. You have an exponent chart. What is 2 to the 5th power? I think I heard somebody say it. Very good. So I am going to move 2 to the 5th power and subtract 32. So now I have 0 equals x squared minus 4x minus 32. Where did I get the 32 from? It is 2 to the 5th power. So once we set it equal to 0, we will factor. So when I factor, I'm going to fast factor. So what I'm looking for are factors of 32. I'm going to start with 1, and I just go down the list. 1, 2, 3, 4, blah, blah, blah. I'm going to do them to myself so that I don't mess you up, but I want you to write them down. Yes, there is. I suppose since we're going to have a calculator on our next quiz, I can tell you. Do y'all want to know how to find factors of something? Yeah. Okay. So in your y equals screen, you'll clear anything out if it's there. So you will set y equals or y equal to whatever you want factors of. In this case, we want factors of 32. So you're going to type in 32. And then you will divide by x. So it is just whatever number you want factors of divided by x. Y equals. Top left. Most powerful button on your calculator, you'll go to y equals. And then in y equals, you will type 32 divided by x. And then you will go to the table. So the table is second graph. Yep, divided by x. So whatever you want factors of, put that number in, divide by x. And then when you go, Adriana just got mind blown. Yeah, so you type it in and then you'll go to the table. In the table, 0 will always give you an error because you can't divide by 0. And then you should find factors. But remember, anything you do in the calculator, I don't know that you even know what you're doing unless you jot it down. So please make sure you still show your work. Second graph. So what times 2 gives you 32? 3 doesn't work. 4 times 8, 5, 6. Do we have more? What do we got? We don't have to rewrite if we've already got 4 and 8. So when we factor, we have to get factors. Which factor pair can we put together to make 4? 4 and 8 will work. It doesn't matter what order you put them in, but one gets a 4 and one gets an 8. Very good. So my middle number is negative, so the bigger number will also be negative. If I have negative 8, would I add or subtract 4 to get negative 4? So I have two x's. I have x is equal to, from the first parentheses, what is x equal to? Negative 4. You don't have to write out this step. I believe we could do it in our head. So the second parentheses, what is x equal to? Positive 8. Before I can circle this, I have to check my answers. I have to factor, get x equals, and then I have to check. Why do I have to check? Yeah, you can't take the log of a negative number. Pretty much, by and large, you should just double check if you get one answer, but usually the answers for extraneous solutions are when you're solving and you get two answers. And sometimes they both work, sometimes neither work, sometimes one doesn't work. So we're just gonna check them. So negative 4, if I plug it into the very first x, doesn't work. Very first one, it's a negative, doesn't work, so I'm gonna mark it out. Then I've gotta check it again. For the 8, if I plug it into the first one, 8 works. The second one, it would be 8 minus 4. Still positive, still works. So the 8 works. So you have to show me that you found both of them, and you have to show me that negative 4 does not work. Also, you cannot just assume that just because it's negative, it will always not work. Sometimes they do work. So you have to just be careful. Okay. So look at your assignment on the back. I told you that you didn't know how to do 11 or 12. You're going to go back to 11 or 12. Both of those are this situation where you just have one log. So you have to rewrite it like an exponential. So you already condensed it. Now you can rewrite it. So I'm going to give you a couple minutes. You may not be able to finish it. Bless you. But I'll give you 2 minutes, even if all you do is give yourself a note, rewrite, or you give yourself a note, like number 4 on the notes. All right. We are gonna regroup. The next problem. So what we have did we just do this one? Did I duplicate this slide on accident? Okay. The next problem, we have no logs. So if we were solving this equation, our goal is to get x by itself. So to try and get x by itself, I have to move everything away from the x. Okay. Well, the first thing I have to move is the +4. So I will subtract 4. What is E? It has a name. Euler's number. And I don't know why this says there. So we will subtract 4. We've got 10 minus 4, so we get 6. My next step, I'm multiplying by 3, so I need to divide by 3. So what we are doing is solving to get the exponent by itself. Okay, our first step is to get the exponent by itself. So there, we've got the exponent or the base by itself. So with this one, we learned last class that if you have base equals base, you can mark them off the same. Do I have base equals base? I'm not 1 to 1, so I cannot do that. I have to rewrite. So with this one, I have to rewrite like a log. So I remember that when I rewrite something like a log, I personally start with the base. So I know the base is E. Oh, hold on. When we have log with a base of E, that's not a regular log anymore. What kind of log has a base of E? Natural log. So this is a special one. So when we rewrite, we have to use ln. We have to use ln because it's a natural log. So I will say ln, and I'll leave myself a space. So when I have natural log, the base is E. I don't have to write it, but if you just want to write it so that you can see where the places go. So I will have E to some power. So the power is negative 2x. So E to the negative 2x power is equal to 2. I almost have x by itself, but I'm multiplying by negative 2. How do we get rid of multiply by negative 2? Divide. So we're going to type that into our calculator. We have ln of 2 divided by negative 2. That is what x equals. Because it's natural log has a base of E. Most logs, it's just you use log. You're going to type it into your calculator. There's an ln button. It's right underneath the log button. So you're gonna type it in, ln up to, close your parentheses, and then we're gonna divide by -2. You get an ugly decimal. That's okay. What do you get? Blah, blah, blah. So, well, we can call that -0.35. That's it. The next thing that we have are word problems. The second word problem we're going to do first because it's so easy. Calculating the pH of something, and it gives you the pH formula. To find the pH, all you do is take and you plug in what you get for the hydrogen ion concentration. So to find out the pH, pH is equal to negative log of what it gives you, 7.8 times 10 to the -6 power. So we're going to type it into our calculator, just like we see it. Negative and then log 7.8 times 10 raised to the -6 power. And you type it in just like that. And you tell me what you get. Yeah, I said, tell me what you get. You got 5.107, blah, blah, blah. So I would say 5.11. We go find, where would that be on the scale? So that would be like right there. It would be a weak base, but it's still acidic. That's it. Don't not do these problems on the homework. They're really easy. The problem above it, we do have to do a little solving. It says Kaylee invests $4,000 into an account. The amount that you invest, that is your principal. Okay, that's your principal. It earns 6% interest. So this is your rate. And more specifically, your rate has to be a decimal. So we have to move the decimal place how many times? 2, so 0.06. It compounds continuously, and when it compounds continuously, we will use the formula. And we want to know when we want T equals. We want to know when she will have $5,085. So that is your ending amount. So to solve this, I'm going to plug in the things I know. 5,085 is equal to my principal, 4,000. E is a number, it's Euler's number, raised to the rate times time. To solve this, I have to get the exponent by itself. To do that, right now, I'm multiplying by 4,000. So what do I do to get rid of multiply by 4,000? Divide. So I'm going to divide by 4,000. So I have, and I don't have to do this until the end. I can leave it all like that until I use the calculator one time. I do not have 1-to-1. I do not have exponent equals exponent. So I have to rewrite. So when I rewrite, what kind of base do I need with E? What kind of log has a base of E? Natural log. So I will rewrite it and I get the natural log with base E raised to the 0.06 times time is equal to 5085 divided by 4,000. This seems really ugly. I almost have t by itself, but I don't. I have to divide all that gross stuff by 0.06. So you have to type that into your calculator exactly the way you see it. When you type it in, type it in, type it in. We got 3 minutes. You have time to type it in. So to type it in, you type in the natural log, 5085 divided by 4,000 divided by 0.06. What do you get? Did anybody get a value? It's just 4. It's 4 point. And then there's 4 zeros and then 3 ones. So that's not big enough to call it anything but 4 years.